All right, let's tackle another example. This time it is question 149. Let's read the question. Question 149. What is the time constant of this circuit? So we are shown an RC circuit. If 8 microfarad capacitor in a resistance of 1000 ohm are connected in series. Part B, if the initial voltage is 10 kilovolt, how long does it take to decline to 500 volt? So let's have a look here. And by the way, this is a discharging problem. We are told that actually there's even a part missing in my diagram over here. So there's a connection right here. So it's a discharging problem. We're told that there's a certain voltage on the capacitor and it will discharge from 10,000 volt to 500 volt. And how much time will it take to achieve this? And so first thing, because it's a discharging problem, we need to use this formula. And this formula is always valid when it comes to capacitor. So the amount of charge is equal to capacitance multiplied by the voltage across the capacitor. Now note, we can transform this equation by replacing the charge with the capacitance multiplied by the voltage. Now the voltage obviously will be slightly different. So it's a capacitance multiplied by the voltage. So the voltage at any given point is equal to the capacitance multiplied by the voltage, the initial voltage. That's important. Initial charge, initial voltage. All right. Now note, capacitance, capacitance, these are the same, which means that we have that formula over here. That will be for part B. All right. So for part A, we are asked, what is the time constant? That one is really simple. Time constant, and actually, I'm just going to write it in full. I've been a little bit lazy over here, just written the answer. But the time constant, tau, even tau over here, there we go, is equal to the resistance multiplied by the capacitor, so it's 0.008 second. All right, fairly straightforward. So in the next question, part B, we are asked, find the time it takes to go from 10,000 volt to 500 volt. So 500 volt is this value over here. It's the voltage as a function of time. Actually, we could even add a little t under parentheses here to state that the voltage change with respect to time. 10,000 is our initial voltage. This is a discharging problem. If we start at the 10,000 volt, well, this is our initial value. That's important, all right? So 10,000 volt, and now we're left with this equation. We only have the time to find. So we take the 10,000, flip it on that side. This is the Euler's number. If we want to cancel out Euler's number, we need to use the natural logarithm. Be careful, many students were using the simple logarithm with base 10. This won't work here. You need to use ln in this case, all right? So make sure you compute the correct value. Now, I will need to erase the top part to complete this, this calculation. So if you need to pause the video, do it now. All right, so we got ln of 500 divided by 10,000. Now note, ln and the exponential, they both cancel out. So we're left with minus t multiplied by 0, divided by 0.08. I will need my calculator for this. All right. So I get basically minus 3 is equal to minus t divided by 0.08. So both minus cancel out. We have the time is equal to 0.024 second, or 3 time constant, by the way. All right. So it's kind of fairly straightforward. You won't be asked questions that are much more difficult than this. You may be asked though, what is the voltage on a resistor at a given time, on a capacitor at a given time? And again, we will be solving some example, solving these type of exact question. That's it for question 149. We're going to be solving a charging problem and then one where we need to figure out what is the voltage on the resistor and capacitor at a given time. All right, see you in the next video.